Okay, here we're going to start the time value of money. And this is going to give us a set of tools that we're going to use throughout the remainder of the course, throughout the remainder of a finance major or other business major. So you can't, overstate the importance here. However, what I've taught this, for over a decade, and what I can see is usually what students get wrong from this is not the actual calculation. It's often they'll do the calculation, but they won't really know what they're doing. So what we're going to go over here in this lecture is what you're actually doing when you use these formulas. In terms of actually doing the calculations, I have online lecture notes which have an online calculator in them, JavaScript, so you can put in the numbers and it'll calculate the answer for you. In those lecture notes, I also do all these calculations in Python, R, C++. I do them in different languages, different calculations. So doing these, and then I also, maybe I'll do a video on just how to do them in Excel if Excel is your preferred method of calculating. So the calculations, like I said, what I also have in my lecture notes is practice problems. So a problem, and then you can choose, a couple answers, multiple choice practice problems. So you'll have no shortage of actually, being able to, do the calculations and then practice them and so forth. But like I said, having taught this for many years, I often found that, it's the student doesn't really understand what they're doing. They can do it, I can give them a bunch of numbers, they can plug them in, but they don't understand what they're doing. So that's what we're going to go over here. So the idea of this is, to derive these formulas. So first of all, we have a single cash flow. So the idea of this is to understand if you're going to use any of these formulas, which you have in your text, which I'll talk about, you only use these formulas when you have a single cash flow. This means, if I have an example here of $62.09 at time 0, which is equivalent to $100 at time 5 at a discount rate of 10%, number of periods is 5. So the idea here is when you're going to move one cash flow around in time, that's what you use here, right? Later we'll have formulas where we move many cash flows at once, and when students get things wrong in exams, it's because they're using a single cash flow formula when there are multiple cash flows, or a multiple cash flow formula when there's single cash flows. So the important thing to understand is if you use any of these formulas, you are only translating a cash flow from one point in time to another, a single cash flow from one point in time to another. Now, how do we derive these formulas? The text will usually start with this. The idea here is if we have some present value, right, and we want to say, well, what is this present value worth at the end of some period? I'm going to use period and year interchangeably here. Then we can sit there and say, okay, well, it's the present value times 1 plus the rate, right? But then if we say, okay, well, how much is it worth at the end of 2 periods? Well, then we can just take this here, and then we multiply it. So the idea is we're compounding here. These formulas take into account, these assume compounding, meaning the present value times R, right? This is present value plus present value times R, right? If you distribute this. We are earning interest on the present value times R, so we're earning interest on interest, right? So this is simply equivalent to present value multiplying 1 plus R times 1 plus R squared. And then we can do this off into period n, and we get this present value times 1 plus R to the n, right? So sort of deriving this formula is not hard, right? But the idea here is, the important thing to keep in your mind is we're assuming compounding. So like in Excel, they'll talk about this as like if you were to get R here, assuming this formula in Excel would be compound annual growth rate. So again, that's also assuming the period is a year. But the idea here is if you're going to use these, you're assuming interest on interest. You're assuming compounding. Okay, so fine. We can use that argument and we get this formula here, future value. To reiterate, what this is saying is you give me a present value. Now, one other important thing to keep in mind here. Sometimes students will think present value has to be period 0. It doesn't, right? We can move a cash flow from time 3 to time 5, right? If I had a cash flow at time 3 and I wanted to move it to time 5, I would just say the cash flow at time 3 is the present value, 1 plus R to the 2, right? So the idea here is we can move cash flows between any 2 point in time. A more appropriate way of saying this might be earlier value, later value. right? However, everything uses present value and future value, so we're going to use that. Just keep in mind, this doesn't have to be time zero, right? This formula works to move cash flows between any 2 points in time. So, given a given value at some point, we can push it to a later period with this formula. One other thing I'm going to mention here, because this is important as we move forward, and this gets messed up all the time. I was driving and listening to something on NPR where they sort of messed this up. But the idea here is, right, if 10% is the relevant discount rate, then 62.09 at time 0 is the same as 100 at times 5, right? So again, money is worth a different point depending on when you receive it. But it's saying it right here, and students often don't get this. These two values are equivalent, right? If you want to say, well, 100 at time 5, that is equivalent to 62.09 at time 0. The reason why I say people get this wrong is, and it reminds me of something I heard on NPR just driving, it drives you crazy. But what they say is, and we'll talk about this later, so I'll just briefly mention it. If you have a mortgage, you pay X times more than the house is worth in interest or something like that. And that is completely wrong. What they're doing is they're taking cash flows and summing them up and saying, all these cash flows you're going to pay for the next 30 years, we're going to sum all those up and we're going to compare it to a time 0 value. You can't do that, right? So one of the things that you should get from this is you can only sum cash flows that are at the same period. So I can never, in finance, the only time we will is when we use a payback decision rule, and then I'm going to say this is horrible, right? But you never sum cash flows at different points in time. So no calculation in finance am I ever going to go 62.09 plus 100. And that's what the NPR people are doing. So the idea here is, because this is equivalent to that. These are the same values. You can't just start, you can't just say this is a time 4 value and I'll sum it with a time 0 value. All right. Hopefully that was clear. Again, we're going to work through this through the entire course. But I often call this the fundamental rule of corporate finance, is never sum cash flows at different periods of time. Good. Now, at least in my course, a lot of exam questions, I don't ask you to calculate this a lot, but I will say things like, if the discount rate goes up, then the future value goes up. So you'll get a lot of questions, something like this. R up implies future value up, right? So you need to know the relationships between these variables. So if I increase the present value, if I increase R, if I increase the number of periods, then the future value goes up, right? All right, good. Equivalently, the most important formula in finance is this, present value, right? And if I haven't mentioned this already, by the way, Next, we're going to do multiple cash flows, right? We're going to do time value of money, multiple cash flow contracts like annuities and so forth. You actually only need these, because what I can do in an annuity is just move each cash flow individually. So in reality, you can get through the entire course just with these formulas. And knowing the annuity formulas may help at periods, but if you have something like Python and these formulas, you're good. All right, but back to present value. This is probably the most important formula in the course, right? So this is saying, I have $100, right, divided by 1.1 to the 5th, right? And that'll move that $100 back to time 0. This here, obviously, was this future value calculation. 62.09 times 1.1 to the 5th. We'll push this value out to time 5. Using this formula, we'll take the value from time 5 and bring it back to today. So, now, why is this the most important formula in this course? Remember, I probably mentioned this earlier, stock and bonds and projects are nothing other than present value. So the value of a company, if you're looking at Microsoft's stock price today, that is we take all the expected dividends Microsoft's going to pay, we discount them at a risk-appropriate rate back to today, sum them up, that's the stock price. So stock and bond and projects are nothing other than present values. So, you'll see this question a lot on the exams. Discount rate, interest rate, discount rate, same thing, synonyms. Discount rate goes up, present value down. So the most important relationship here is interest rate up implies decrease in present values. And then on later exams, I'm going to say if the interest rate goes up, what happens to stock values? And then I'm also going to ask if the interest rate goes up, what happens to bond values? And what I want you to see is this is the same question, just worded 3 different ways. This is not 3 different questions. Present values, stocks, bonds are present values, right? So all of them will decline when the interest rate goes up. So again, you'll see this, at least in my course in corporate finance, for at least three exam questions, right? But they're all saying the same thing. Obviously, if you discount something for a longer, the number of periods increases, then your present value will also decline. Holding everything else constant, if the future value goes up, your present value will go up, right? So those are important relationships. What we have down here is we can also say, okay, well, given some future value, and some present value, and some number of periods, what is the annual rate of return? So this you'll also use quite a bit. If I want to sit there and say, on the exam question I'll give you for this is, you bought a stock for $100, 10 years later you sold it for $200, so you doubled your money. What was your annual rate of return? And it's a little over 7% there, right? That's the rule of 7, so that's why you'll see that a lot. Doubling over 10 years, about 7%. So, but you can calculate it exactly with this, right? So the idea here is this is going to give us our compound growth rate, right? Good. Now I've written it 2 ways here, right? Depending on if, of course, you should be doing this in Excel, or some programming language. Hopefully you're not doing this on a calculator, right? I sort of discourage calculators because, again, throughout the rest of your career you'll be using Excel, so we'll use it on the exam. But the important thing to know, I often would do this back when I was I did this on a calculator. I would do it this way. But you can do it. You can take the nth root of future value divided by present value, which is the same thing as you're saying raise it to the power of 1 divided by n. And this may seem, this is one of the things that I often want to teach undergraduate students. Because there are also Excel formulas you could use. I would advise you not to use the Excel formulas, just to do something like this, but you can use them if you want. Canned formulas. But just read the documentation on them. But here's the thing, and this is one thing students often don't get. Sometimes they'll say to me, well, why do you give it to me in this formula? The text says this formula, and they want to get it in the way they want it. But here's the thing, when you go to work somewhere, you're studying here to get a job, right? And when you go get a job, you are starting at the lowest part of the totem pole, right? So people are going to do things the way they do it, and you have to understand how they're doing it. Does that make sense? Another way of thinking about this is also, when you go to work somewhere as an analyst, you're going to inherit a bunch of spreadsheets. And who knows how they did this calculation? They may have used the canned Excel formula, right? They may have done it this way, they may have done it that way. Who knows, right? But the idea, you have to be able to notice that they're all the same calculation, right? So the idea here is, I would strongly advise you, right, when something can be done in multiple ways, to learn all the ways, or at least be able to recognize them, because at the end of the day, you're going to go work somewhere and no one's going to care if you don't know it that way. They'll say, well, learn it that way, right? That's if you were working for me, I'd say, I'll learn it that way, or I'll bring in somebody who will, right? So the idea here is, when there's multiple ways to do it, you should be responsible to know each way. So in the future in this course, will I write this or write this? Whatever I feel like at the time. You just have to know that they're the same. All right, good. So lastly, we have the number of periods, right? So what we have here is the number of periods. So given a particular present value, given a future value, given a rate, how long will it take for that present value to become that future value, right? So this is the log. Right here I have natural log. It doesn't matter what log base you use, right? You can, so long as you use the same log in the numerator and the denominator. This is the log of the future value divided by the present value divided by the log of 1 plus the discount rate. So you can answer that question. And the interesting thing here is these are really also useful for retirement. So one of the things, and you will hear this, we'll do a lot of saving for retirement sort of calculations. And sometimes you'll hear this rule of thumb, and this is a good rule of thumb, right? It doesn't matter, something to the effect of, it doesn't matter your rate of return, or time in the market is more important than your return in the market. What this is getting at is, really, it's unlikely you're going to beat the market with your retirement, particularly if you're working a job, so you can't expect to work a full-time job and then beat the market, right? Most people who, their full-time job is to beat the market, can't beat the market, right? So, this is good, so usually what I often advise people is in your retirement calculations, take the market return as given, right? So you're going to earn 9% per year, right? Which might be the S&P 500 plus dividends. And take that and then see how long it's going to take you to reach your retirement goals. But really, messing with the rate of return is very hopeful, right? It's more informative to sit there and take the rate of return as a given and then use, a formula like this to sit there and say, okay, well, if I have this amount today and I invest it at that rate, how long until I have whatever I want? And keep in mind, this is a single cash flow. What you could do is, if it was like a retirement, you could do a single cash flow and just, I'm going to have this, I'm going to receive this amount today, I'm going to receive this amount next month, and then push out those cash flows individually using this formula multiple times. What we'll do, however, is also show you a future value of annuity, which will just push them all out at once. But each of these is important, right? And of course, getting back, if the future value increases here, then the number of periods increases, so we can sit there and say, if we get an increase in future value, this implies we need more periods, right? Equivalently also, if we have an increase in rate, this is what I told you is probably unlikely, then we need fewer periods, right? So, now note here in this formula the rate cannot be zero, because then this would be zero, and so this is defined for positive interest rates. Good. Also, if the present value goes up, then the number of periods goes down. So we can see present value increased, then it implies the number of periods goes down. But for each of these formulas, you should be able to say the relationship. Because again, this is important. When you go work somewhere, you are supposed to know that if interest rates go up, stock values go down. If interest rates go up, the value of all projects go down, and so forth. So these relationships, you're intuitively supposed to know if we want some greater future value and our rate's fixed, then it's going to take us longer to get that future value. These are all intuitive relationships that are important as a manager and to understand business decisions. All right, good. I'm going to leave it at that. I'll talk about multiple cash flows next. Keep in mind, like I mentioned, in the links, in the description of these videos, I should have links to lecture notes. So if you're sitting there going, well, I want a practice problem, then go to the lecture notes, and there's some practice problems there. Also for everything I do. So for sustainable growth rate, internal growth rate, the video I did before this, there's lecture notes with practice problems and so forth. So go check out those for some practice problems. Have a great day.